Hi, here we will discuss about k nearest neighbor classifier. First, we should know what is the difference between parametric and non-parametric classifier. In the parametric classifier, we will have set of fixed parameters that used to determine the probability of the given model. The best fit in linear regression model with one dependent variable and one independent variable. The dependent variable is y and independent variable is x, which is used to draw the regression line with optimized parameters such as intercept c and coefficient m in the straight line equation y equal to mx plus c. So this type of algorithms are called parametric algorithms. In classification algorithm, we will get a decision boundary that separates the different target classes. In logistic regression, a decision boundary is determined by the optimizing parameters. So like we will have the classes like this, then which is divided by the decision boundary. Here this decision boundary is determined by the parameters. But in non-parametric machine learning algorithms, there is no need of any assumption of parameters for given set of samples. So here the number of parameters are growing with size of the training samples. That means the learning algorithm needs to keep around an entire training data set even after the training phase. So here the non-parametric algorithm example is k nearest neighbor algorithm. This is belongs to instance based learning model because which is not transforming the training samples into more general statements. So that is why it is called instance based learning. And also, instead of the given training data is simply stored in the memory locations, whenever the new test sample is encountered, then the set of similar or related instances retrieved from the memory which is stored earlier that are used to classify the new testing sample. That means here the training data samples are stored in the memory location without learning. So whenever the new data sample is coming into the model, at that time it will use the similarity measures from the stored data samples. Hence the instance based learners never form an explicit general hypothesis regarding the target function y. The instance based learners simply compute the classification of each new test instance whenever it is needed. The training data is given in the form of features and its corresponding target output. So here from this, not learning anything by the model. So whenever testing sample is encountered by the model, at that time it will retrieve the samples, training samples from the memory, and it will predict the classification. So here we will see about k nearest neighbor algorithm, which is belonging to the instance based learning. So here which is also one of the supervised learning technique. As we told, there is no parameters. The parameters will grow when which is when depends upon the uh, input training samples. So there is no need of making any assumption on the training data. The KNN assumes that all the given data points in n dimensional space, like a two dimensional space or three dimensional space, like that, and we have to consider the k number of neighbors, which is also using the similarity between the testing data point and training data points to classify the new test data point. And also it does not learn from the training data set at the training phase, because the instance based learning model just stores the data set in the memory locations. Whenever the new test data point is coming into the model, at that time it will take the action to find the similarity between new test sample and the training samples which are stored in the memory location. That's why which is called lazy learning. And also assign a new test data point into the category based upon the similarity measure. For example, let's consider an image of creature that looks similar to cat and dog. We will take images which is having the picture. One picture is having the dog and another picture is having the cat. Then these are all training samples. Then we can get one more picture which is having either cat or dog, right? Cat or dog. So when you are showing to this testing sample to the kid, that kid need to find out the similarity between this picture and also this picture. So based upon the similarity, it will identify the creature which is available in the testing sample. So this is the example for KNN learning. Now, what is the algorithm in KNN classification? First, what we have to do, we have to collect the training samples. So here in this diagram we are having the training samples. So here this is the duck, here one more duck and one more duck, and here we are having the chicken, and here we are having the cock. So these are the training samples we are storing in the memory location. Then we are getting the testing sample. The testing sample is compare the similarity between each and every sample which is stored in the memory locations, right? So here the k number of neighbors also has to be selected. Then the new test data point is received from the test data set. So to find out the similarity between the testing and training samples, training and testing samples, we can apply the Euclidean distance metric or Manhattan distance metric to calculate the distance of k number of neighbors. So here we will calculate the distance between the each and every sample in the training sample and testing sample. So here you may get the distance value, like here the distance may be for example 5. Here you may get the distance may be a 5.4. Here it may get the distance between the 4.2. Here it may be a 7, it may be a 6. So we got the distance value between each and every training sample with the testing sample. So after that we have to arrange the distance values in ascending order. So here the 4.2 is the minimum value, then 5, then 5.4, then 6.0, 7.0. Then we can take the k number of top values. Suppose my k value is 3. Here we have set the k value is 3. Then I can select top 3 values as a nearest neighbors. K is nearest neighbors. Okay, so in this nearest neighbors we can select how many number of data points to each category. 4.2, 4.2 is, this is belonging to the duck, and 5.0 is also belonging to the duck. Okay, so this is 5.4 also belonging to the uh, duck, right? So all the categories are belonging to the duck, right? So now my need to new test sample is belonging to the maximum number of neighbors duck. Suppose my k value is k value is 5. If my k value is 5, here what will be happen, I will select all 5 k number of neighbors. Then here 6 is belonging to the cock and 7 is belonging to the chicken. So here which is the maximum number of categories? So here the duck is appearing 3 times, cock is appearing 1 time, chicken is appearing 1 time. So the maximum number of category classes duck. So the test sample is belonging to the class duck. So this is the way to classify the given test sample using k nearest neighbor algorithm. So here we have to use distance metric, the Manhattan distance metric, which is called L1 norm, another name. Here we will take the 2 points x1 and x2, x1 comma y1, x2 comma y2 in n dimensional vector space. Then we can apply the Manhattan distance metric mod x1 minus x2 plus mod y1 minus y2. So here for all the samples, m number of samples, we can use the summation of I equal to 1 to m mod xi minus yi. This is for m number of training samples. M number of training samples. So this is used in the real time integrated circuits where wires only run parallel to the x or y axis. Example is given here. This is x1, x2, x3, x4, y1, y2, y3, y4. Then values calculated here. And also Euclidean distance, which is called L2 norm or L2 metric. So which is using the square root of sum of the squared differences of the elements of in the two vectors using Pythagorean theorem. The formula is here again for m number of samples, square root of summation of I equal to 1 to m of xi minus yi whole square. So here I is varying from 1 to m. Then third distance metric is Minkowski distance. Here again which is similar to the Euclidean distance, but we have to select r value in the power, r value. Okay, so this r value determine the power of this distance coordinates, this, right? uh, Example here in this diagram, you look at that we are having the training samples belongs to two categories, category A and category B. Then we are receiving the test data point. So this is the test data point we are receiving here. Then initially we are choosing k equal to 5 as the nearest neighbor, and here the calculate the Euclidean distance between new test data point and all the training data points. So here when you are calculating the distance, you will calculate like this, distance between all the data points and test data point. Okay, so when you are calculating like this, you will get all the distance metrics. Then you arrange the distance metrics in ascending order. Finally you can apply the k number of neighbors. So here my k value is 5, so I am selecting top k minimum distance value. So 3 belongs to group A, 2 belongs to group B. So here maximum number of data points nearest to this test data point is category A, green color data point. So the test data point is belonging to the category A. Here example is given. Training data set is given with feature x1, x2, x3, x4. So four number of features and output label. So it is having the five samples. Then these are all training samples. We are using the k number of neighbors, k equal to 3. Then I am adding the testing sample. So this is the testing sample. So this testing sample is having the features x1, x2, x3, x4. But what is the output label? So we have to identify the output label by applying the KNN algorithm. So here first we have to identify the distance between test data point and all training data points by using the distance metric. So here I am using the Euclidean distance metric. So here the test data point 37 minus 35 whole square, then plus 50 minus 35 whole square, then 3 minus 2 whole square. Okay, inside the square root you will get the 15.16. Like that, the second data point 22 minus 37, then 50 minus 50, 2 minus 2, so you will get 15. So likewise you have to calculate for all the 5 data samples. You are getting 152.23, 122, 15.74. From this we have to make all the values in ascending order. So now all the 5 samples are arranged based upon the distance value in ascending order. Here our k value is 3, so we have to make top 3 k values. So in this top 3 k values, you look at that what are the output labels. So s is appearing 2 times and no is appearing 1 time. So now our the testing sample is belonging to the category yes. Category yes. So here we are selecting the k equal to 3 number of samples. So based upon that, yes is appearing 2 times, no is appearing 1 time. So the new sample is belong to the yes. How to select the k value? Okay, mostly k value will be preferred as odd number, right? In that odd number also 5 will be the most preferred value. Any low value for k, like k equal to 1 or 2, there is the possibility of noisy or outliers in the given model. So mostly they won't prefer k equal to 1 or 2, and also they won't prefer even numbers, even number k value, because there is the possibility of misclassification. You see, test data point will be available here, k equal to 4, here also k, two samples, here two samples. So there is the possibility of misclassification. So mostly k will be prepared as a odd number. Large values of k will be good, but it is computationally expensive because it will calculate every time the distance between all the training samples. So if you have large value of k 7, 9, 11 or 15 like that, then it will take more time. And cross validation test KNN algorithm can be done by using the different values of k. From set of k values you can select the optimal value. And how can we split the data points? So here the outliers can be observed if any value is lie so far away from other data points. Suppose if I am having the data points like this, so this is far away. Okay, so outliers can be detected. So removing this data to increase the accuracy of model. And for the prototypes, minimum number of data points in training set is required to recognize the outlier data points. These are the points are correctly identified as a non-outlier data points. That outlier data points, non-outlier data points are called observed data points. So in practical, we have to use pre-processing step like processing the missing values and the error values. Then apply the KNN algorithm by collecting the training data samples. You can import the KNN classifier from the sklearn package. Then you can set the number of neighbors as on a parameter. Metric you can set on parameter. P is the power of Minkowski because Minkowski is having xi minus yi whole power r then 1 by r. So this r value is set by using the parameter p. Then we are fitting the model with training data, predicting the result for test samples. Finally, we are calculating the confusion matrix from which we can calculate the all required evaluation matrix. So here the KNN can be used for handwritten digit classification and fast content based image retrieval, and we can use it for identifying the behavior of data points as normal or abnormal and fault detection in semiconductor manufacturing process, because which is very useful in linear integrated circuit designing. The advantages, it is very simple to understand and interpret, and also which is useful for nonlinear data because there is no assumption now about the parameters. Okay, it is non-parametric algorithm which is also versatile. It can be used for classification and also regression. There is the one of the KNN regression algorithm. And disadvantages, for large data it will be take more computational time, and for large dimensionality again which is taking more expensive, which is need of adequate distance metrics. Then accuracy is depending upon the quality of the data, and outliers are making decreasing the accuracy, and which is sensitive to scale of the data and irrelevant features, which is requiring high memory because we are storing the data in the memory locations instead of learning from the data. So that is one of the disadvantage. So with this, KNN classifier is over. Thank you.